Okay, so this question is about the regression line, and we want to figure out whether there is a regression or not. All right. So the first remark here, if the R is very high, most likely there is a regression, right? So this is pretty high regression. Now, whether the numbers is high or not, everything will be relatively to the alpha, all right, which is 0.05. So let me try to explain how this works. This one. So usually on a regression, which for your case, all right. So always we have this like normal distribution, right? So this is 0 actually, all right. So this is the R equals to 0, and we have two cutoffs. Usually this is a cutoff, right? And these cutoffs here, they are always between reject. This is going to define the reject one. And this is as well reject zone. And of course, do not reject zone, right? So over here, do not reject. So whenever we say reject and do not reject, we are always referring to 8.0. So here, let's try to understand what is 8.0. 8.0 for regression is always the R equals to 0. And H1 is always R is different than 0. And we are really familiar with this. The problem is we have a regression only whenever the R is different than 0. This means a regression. Whenever we say there is a regression, this means there is a relationship between the X and Y. And if I end up to not reject, all right, there is no regression here. And of course, if I am doing a regression scenario, I want to be in the H1. I want to have the H1 correct, right? So every time I'm doing the regression. So if I want my data, I want it always in here or in here. That's where it should fall. All right. So how can I determine these 2 points? These 2 points are called the T critical, right? The critical values, right? So whatever T or not. Okay, so one of them is going to be positive and one of them is going to be negative, and these values are given to you by a table, right? What you need in order to identify them, you need two pieces of information: degree of freedom, which is n-2 always, and you need the alpha, right? And this is given to you from question. So if you read your question here, the entries, there is 1, 2, 3, 4, 5 entries. So the n is 5, and therefore this one is going to be degree of freedom is 3. The alpha is giving you the alpha here 0.05, and if you do that, this is 0.5. So these two values here, these two information, that's what you're going to give you the T by the table, T critical. So the critical, what is it? In order to do this, you will need the table. The calculator, I don't think it's possible to do it. So go to your tables. This is the list of all the table, and the table that you're looking for, all right, is this one. The PPMC table, all right, critical value for PPMC, which is table. You go there, you click on the menu, and then you table I and J here, and this is, so this is your table, and you can see only the first part, right? So we don't care about the second table. There are two tables, we care only about the first one. So giving you degree of freedom here, n-2, and we have 3, and we have the alpha 0.05. So this value that we are looking for is 0.878. All right. So if I go back here, 0.878. All right. So what do you mean? This value is going to be 0.878, and this one will be minus 0.878. So now the R that you had, right? I don't need table anymore. All right. The R that you had on your question is going to tell you the R equals 0.943. So this is the R tests. right? So well, I should say this is R critical here, R test, right? The R test is 0943. Okay, 0943. So 0943, where I'm going to plot it in, whenever I put it in, so obviously it's bigger than 0878, and that's going to go somewhere here. All right, and of course I am within the rejection zone. You see it here, reject is 0. Remember, reject is regression. There's a regression. So your choice would be there is a regression, and now you're going to come up the time where you're going to put the A, the B, and so forth. So let me make a small remark about the A and the B. Your book is using y hat or y equals to A plus bx. So what does this mean? The B is the slope and the A is the intercept, the y-intercept. Some other books, they use it differently, the A, the slope, and the B, the y-intercept, but just to need to know what you're using, right? So this is what you need to refer to. And why we need to do this, we need to, because right now we're going to go to table and we're going to look for them. So how do you look for them using the TI-84? And I think this is the easiest way again. So let's see. I'm going to go to stat, and then I'm going to edit the table, and the table has stuff, so I'm going to go and clear it. Second plus. So right now I'm going to go to clear all lists, number 4, enter, enter again. So it's done. So now whenever I go to stat and edit, enter, I have an empty table, which is great. Right now I'm going to enter the A's in the L1 and the time in L2. So the A's start with 25.1. So you gotta be careful entering the numbers here. Sometimes I do mistakes because I'm using the mouse. The keyboard it seems not efficient with the interface on the computer. So you just have to pay extra attention. It will be easier if you have the physical calculator. So I am in 27.1 right now and 27.1. Okay, so now I'm going to go to L2 and enter the data at 66.5, 69.7, 74, 89.2, and 81. So after you enter the data, try to take a look whether you entered the numbers correctly or not. Okay, great. Now I'm going to do the stat again. I'm going to go calculate, right? I'm going to stay in the calculate one. And you can see here, number 4 is giving linear regression as well, but it's AX plus B. You don't want to use this. You want to use A plus BX. And you don't see it now, but if you keep scrolling down, you can see it here. Number 8 is linear regression A plus BX. All right, so that's the one that you are supposed to use. Enter. The X list in L1 is good. L2 in Y list, good. Frequency, skip it. For the store of the equation, this is important because I'm going to have to answer to another question later. So what I'm going to do, I'm going to go to vars. I'm going to go on the right, y vars here, and I have to select the function. Enter, and make sure you select the first one, right? y1. So I'm going to store it in a y1 function, all right? And then calculate right now. So you're going to get the value that you need. So I'll go and type in right now, the A is minus 170, minus 170. And I think they want at least 3 decimal places. So 524, 524. And the B would be 9.4339. So 434. 434. 9.434. Great. And then the next part, I want to calculate right now, if a service person is 26.6, they want to figure out what be the predicted value, right, y hat. So you can plug it into the equation here and do it by the calculator, or because I did storage here, I can clear this. I need to go to vars. I'm going to go to the y bus here, and then I'm going to select y function, the function, sorry, and then I select y1, right? So enter. So I have to have y1. I cannot type it in as y1. I have to go through all this process. Open a parentheses. Right now I'm going to plug in 26.6, 26.6, and close the parentheses. And that's it. This is going to be 80.4. 80.4. I need to round how many? At least one decimal place. Yeah, at least one decimal place. That's good. That's all. So either 80.4 or 80.42. All right, one of them should be good, right? Okay, that's all for this question, guys.